Hello? Hello, welcome. So I'm going to talk about advanced Alexa skill building. Unfortunately, we only have 45 minutes, so there's not so we can cover a lot of things in a very deep way. But I'll try to go into the topics that I wanted to share with you today. Okay? So let's get started. So there's been an evolution of user interfaces, right? If you think about the 70s, for example, we had basically character mode screens like terminals, right? And before that, even before that, we had like punch cards. And every 10 years or so, we started, upgrading our UI experience, and we went through the GUI. Then we switched to web interfaces. Finally, we discovered the mobile phone. Probably some of you remember when you first tried, a mobile phone for the first time, right? When you do pinch and zoom, etc. It was really like a magic moment, right? So these moments are something turned out to be like a revelation to some degree. And at the present time, we are going into what we call voice, right? And voice user interfaces. And we see this as a revelation. We don't realize the impact that these jumps in UI technologies have, because we basically get used to it right away, right? You probably, when you probably use a mobile phone for the first time, you immediately get used to it, like in less than a day, a couple of hours, right? And you started to just go with it, right? But if you think about it, what would happen if we just skip a few generations and we show someone a completely different interfaces, like skipping all these steps, right? So if you think about it, this is a video that I wanted to share with you. Let's start again.
Computer. Hello, computer.
Just use the keyboard.
So as you can see, these jumps in generations can be very, very fundamental if you skip, some of those steps. And this is a nice example of Scotty just trying to use a mouse as an intercom, because for us, the Star Trek computer is a very, very nice example of the potential of Alexa, right, and what Alexa can do. So the idea here is to have natural conversations, right? There's a major advantage in using conversation, and that is that we are pre-programmed to understand voice, right, and to deal with voice. There's no need to learn a new user interface when we are dealing with voice, right? It's a natural way to communicate. You just speak to the technology, right? And this becomes very, very obvious when you see kids and you see elder people interacting with Alexa, for example. You'll see that they get it right away. I mean, there's no need to explain. There's no need to adapt to a user interface, to a technology. Basically, the technology is bending and is adapting to us, right? And that's super, super, super interesting. The idea is to create, when we are working with Alexa and building skill, is to create experiences that are relatable, that are personable, usable, intuitive, and everybody would know how to interact with that kind of skill if you basically mimic like a human conversation, right? So let's take a quick look at the infrastructure or the architecture that we have in the Alexa service. So first of all, let me tell you that Alexa is a service that is running on the cloud all the time, always improving, right? And the device basically, it's like a very intelligent microphone that is streaming voice data into this service. And this service creates does a few steps that are important turn that into a specific text, right? For example, we have the AI that we do on the Alexa service. It's called like automatic speech recognition, or ASR. You probably heard about it. This is a step where we're basically turning sound into text, right? What the people are saying, we turn it into text. But that's not it. That's not the only thing that we are doing. We're also doing natural language understanding, and that's basically taking out meaning of the text that is processed in the ASR step, right? So basically, when you have a piece of text and someone said something, you turn it into text, it might mean very different things depending on context, right? So we need to apply a natural language understanding step to basically determine what the user really wants to do, right? After that, when we process that information, we basically send it to a service, what we call a backend. We will see more about that later. And that backend is basically what you create and is responsible for providing the data back to the user. Basically, a skill needs to find useful information, right? For example, you want to give directions from point A to point B in a skill. You basically need to fetch that information from somewhere, right? So that's what your service will be doing. And it will be coming back to the Alexa service and as text. And the Alexa service will turn that text into speech with a process called text-to-speech, right? That will go back into the device. So as you can see over there, we have steps where we're dealing with audio. The person over there is obviously the user, right, or the customer. And the audio is basically coming back and forth via the Alexa service. And it's the Alexa service that will basically consume your backend and your service to basically make a skill interesting, right? Or help a skill do something. Now, there's also some interactions over there. When you see visual, we provide a layer for providing visual cues with Alexa skills. And for example, you can send images, etc. But that's just like a secondary support experience to the voice experience. So we wanted this to be like a voice-first experience, and then you can basically provide some goodies on top via visuals. And visuals are supported both in the app, in the mobile Alexa mobile app, where you can actually see any images that you're sending from your backend. Also use it for other kinds of things like account linking and some functionalities that require the intervention of the app. But you can also see those visuals in what we call multimodal devices, which are devices that have a screen. We have released devices that already support screen, like the new Echo Show, for example. And those devices, besides being a great speaker, a great intelligent speaker, they are also a screen-enabled and can complement a skill experience. Like for example, suppose you're opening a skill for recipes, you can basically hear what the recipe is about. You can follow the recipe, but probably you can also see the ingredients, stuff like that. Okay, so as I told you before, for those of you that haven't built an Alexa skill, it involves two basic parts. One of them is the front end, and the other one is the back end. We call the front end the voice interaction model, or the voice user interface, and it is the part where you define all the conversational part of the experience, right? So basically, it's what Alexa needs to understand from the user and what the user wants to do, right? So you can define that, for example, if you're doing a German skill in German, but you can also define the same information for English US if you want your skill to also be supported in English, for example. So once you define that voice interaction model, you basically define the spoken experience of the skill. Then you need to obviously provide the backend, which is where the information is coming from, because you need to most probably return useful information to the user. So that is the programming logic, or the backend. And for that, we tend to work, it's very popular to work with AWS Lambda. You probably heard about AWS Lambda serverless technology. Very easy to create snippets of code, for example, in Node.js, JavaScript. This code is basically not running when the Alexa service is not using it, and it will be just used on demand, right? Okay, so some of the advanced topics that I wanted to share with you today are dialog management, synonyms, and memory. Just to be clear, we will see some snippets of code, right? But this is not obviously a code-heavy session. But I am more than happy to share any. If you want to show me code after the talk, we can take a look at your skills. I'm willing to stay here for that, no problem. So dialog management, synonyms, and memory. So let's take a look at what I mean by this, right? So in order to illustrate some of the advanced topics, we will use a skill called pet match. Pet match is a skill that basically asks a series of questions, like, for example, what kind of dog do you like? Do you like quiet dogs or high-energy dogs, mid-energy dogs, or low-energy dogs? Do you like more like a family dog or a guardian kind of dog, etc.? Based on those parameters, the skill will try to match you to a specific dog breed, recommend a specific dog breed, right? So this example is a very good example for some of the advanced topics that we'll be seeing today. And this example is available in github.com/Alexa. You can actually go there, look for pet match, download it, and use it right away, modify it, etc. Very, very good example for a conversational skill. So let's move forward. Let's take a look at what would be a first interaction with pet match.
Alexa, open Pet Match.
Welcome to Pet Match. I can help you find the best dog for you. What are 2 things you are looking for in a dog?
Match me.
There are dogs that are tiny, small, medium, and large. Which would you like?
Medium.
Are you looking for more of a family dog or a guard dog?
Guard dog.
Do you prefer high energy or low energy dogs?
Low energy.
So a medium guard low energy dog sounds good for you. Consider a bull mastiff.
So as you can see, this was more a conversational experience rather than like a one-shot experience when you specify all the parameters that you're interested in a dog, right? So basically, there's a back and forth happening between Alexa and the user. So this is one important topic that we will see, and we call this dialog management. So dialog management. Before introducing dialog management, we need to go through a few concepts. This will be familiar to the guys that have already created skills and not so familiar to guys that haven't created skills. So let's go through them quickly. So the first concept is the invocation name of a skill. First of all, what's a skill, right? So you can think of a skill like the equivalent of a mobile app with a lot of differences, but just to give you an idea, this would be similar to an app running on the Amazon Echo or on Amazon Alexa. The difference is that the skills are not deployed into the device. Like when you typically have an app, you're downloading it, it's been deployed on the device. These skills are running in this service that I mentioned, the Alexa service, right? So the device doesn't host Alexa skills. The device is basically streaming, and it's accessing this huge database of deployed skills that are running globally in the Alexa service. So when you create a skill right now, you have the potential to deploy globally. So it's immediately available to everybody. So when the user tries to use a custom skill, they have to basically call it by a name, right? So we call this the invocation name. In the case of pet match, the invocation name is pet match, obviously. And there are many ways and you can call the skill. You can say, for example, open pet match. Obviously, this is all, we have the equivalent in German, right? So I apologize for that. I'm not a German speaker. I'm actually a Spanish native speaker, and I'm working in the Spanish Alexa team. But this is all equivalent. We have the same things for the multiple locales that we support. We have 11 different countries right now, 11 different languages. And in English, it would be, you can say open pet match, but you can also say ask pet match for a dog, for example, or ask for a dog from pet match. So as you can see, the difference between the first sentence and the second sentence is that in the first one, we are just saying open the skill, right? Open pet match. While in the second sentence, we are saying open the skill, but we are also passing like a command or saying an utterance. We call those utterances. It's basically phrases that come after or before the invocation name, right? So we are already in the second sentence, we're already specifying exactly what we want to do besides opening the skill, right? So the same thing happens in the third sentence, but the order is backwards, right? So we are specifying what we want to do, but then we are mentioning the invocation name. And in the last one, we are doing exactly the same thing as the second one, but we are using tell, right? We're using a different way. So there are multiple variations. We call that the invocation name. The invocation name is not the same as the skill name, because when you create a skill, you assign a name for it, but the name is what will show up in the skill store. Basically, it's the name when the user is searching for specific skills in the store, they will find that name, and that's not the same as the invocation name, which is how you open the skill, right? They don't have to be the same thing. They can be different. So I mentioned utterances, right? Which is these phrases that go on top of the invocation name, where you're telling the skill that you want to do something specific. Now, that phrase can be, give me a dog, or that phrase can be, I would like a dog that's tiny, long hair, and playful, for example. So if you think about that phrase, we have several variables there, right? There are things that we can actually use to do a proper matching to a specific dog, right? Because we can have a web service or an API that actually can grab these parameters, like for example, size of the dog, type of hair, and temperament, and basically find us the right dog. But for that, we need to allow for variations. We need to allow for the user to say, I want a tiny dog or I want a large dog, right? So that's variable. So we can define that in our utterances when we create the skills, and we call that slots. Okay? So the slots are basically the variables that you can see and you support in your sentences. The other example, the example below is very similar. Okay? So when the user can provide slots, they can give us a phrase that comes right after the invocation name, for example, Alexa open pet match, and then they can specify a whole set of slots or a whole set of parameters like Alexa open pet match and give me a dog that is high energy, has long hair, and it's good for the family. They are, in one sentence, they are specifying everything, but that is not very natural, right? And that's not, and that it's kind of painful if you rely on your skill to basically support those kinds of interactions alone, right? It's highly unlikely that if we have like 8 slots, for example, or 6 in that case, that the user is going to specify the whole 6 slots in a single invocation, right? That's not going to happen. We cannot expect that from the user. So let's take a look at what happens when the user provides just limited information.
What time of day is it, and what style of cuisine do you want?
I want breakfast.
Well, what time of day is it, and what style of cuisine do you want?
I want breakfast.
What time of day is it, and what style of cuisine do you want?
What's wrong with you?
I'm sorry, I don't know that one. What time of day is it, and what style of cuisine do you want?
All right. It's the afternoon, but I want breakfast.
Got it. So you want breakfast and lunch?
No. I want breakfast.
Well, what time of day is it? And what style of cuisine do you want?
So this is a great example of a skill that was trying to basically fill all the slot information. The skill requires a set of slots to be filled, and it expects those slots to be filled right away. However, the user is providing limited information, just providing one slot, information from one slot. So the skill doesn't know how to handle that, and basically breaks the whole experience, right? It's super frustrating. So we need to switch to a more conversational style, where we can actually allow the user to provide information partially, right? And engage into a back and forth conversation where we are collecting, from the skill side, we are collecting the information, and when we are ready, we can provide a recommendation. And that back and forth has to be natural, has to feel like a conversation, like talking to an agent or talking to a friend, right? So fortunately, Alexa has what we call dialog delegation. Dialog delegation is a technology that we have to allow the developer, the skilled developer, to specify the slots that we need for a specific recommendation or for a specific service, and allow Alexa to go back and forth in that interaction with the user to collect the information, and then when all the slots have been filled or all the parameters have been passed, we come back to our backend and we have all the information and we can actually do whatever we need to do, like call an API, etc., right? But that is semi-automated. Alexa is basically handling that back and forth, asking questions about what's missing, etc., right? So if we do this, we are happy because we just need to worry about when the conversation is over or the dialogue is over, so we have everything that we need. But the user is also happy because the user can provide the information however they want. They can provide the size of the dog first, they can provide the temperament of the dog first, they can provide temperament and size, but not the fur type, and they can provide that later on a second round, etc. It's up to the user, right? So it feels natural to the user. So let's take a look at the second interaction with Pet Match.
Alexa, open Pet Match.
Welcome to Pet Match. I can help you find the best dog for you. What are 2 things you are looking for in a dog?
Small and high energy.
Are you looking for more of a family dog or a guard dog?
Family.
So a small family high energy dog sounds good for you. Consider a bull terrier.
Okay, so as you can see, the user is providing limited information, like for example 2 parameters, but it's already providing more than one. So basically the skill was able to handle that, but 1 parameter was missing. So Alexa engaged into a conversation to basically grab the missing parameter to basically fulfill the intention of the user and get back with the information that's needed. This was handled via dialog delegation. So when you think about dialog delegation, instead of building a skill where you're thinking about the interaction with the user as a tree or as a graph, it's super hard to do it as a graph when you are designing the conversations, because you need to think about all the multiple possibilities of where the conversation can go, right? But we rather like to think like in a frame UI way, because when you're dealing with frames, you're basically encapsulating functionalities or dialogues, and you can go in this back and forth to basically grab the information that you need, and you're basically fulfilling this module for a dialogue that is basically going to achieve a specific thing that the user wants to do. Because when you create a skill, you can have multiple, you can support multiple intents or multiple things that the user wants to do, right? In this way, we have these modules that are self-contained and can process a specific conversation and get the information that's needed to use, for example, an external service via an API. So when it comes to dialog management, we are zooming into one of these frame UI modules, right? We're zooming in right now. And basically, we are collecting slot information. We are collecting size, energy, temperament. And when that information is missing, we are using prompts. Alexa is using prompts to actually prompt for the information that is missing, okay? When that is happening, we have a dialogue in progress. And in each loop, we keep coming back to the back end with a status that says that the dialogue is in progress. At any time, we can take over that conversation if we want, but we can just keep waiting until the dialogue is not anymore in progress and it's basically completed. When it's completed, that means that we have filled all these slots of information and that we can process and we can access our API. In this case, PetMatch uses a PetMatch API. Okay, so in terms of code, when it comes to delegating a dialog, which is saying, Alexa, please handle this dialog for me because I want to collect the slots and I don't want to deal with this back and forth with the user, you basically need to delegate, to use a delegate directive. It's just that easy. You basically specify the intent. The intent is what the user wants to do, and we have handlers of those intents in the backend, right? And you basically need to delegate that, and Alexa will automatically look for the prompts that you have defined to collect that information. Okay? So in terms of code, supporting this kind of interactions in the backend, it's only three lines of code. So, sorry, someone told me we have a Q&A, like a 5 minutes question. I just saw a banner over there. If someone wants to do a question right now, I'll just give you the opportunity. Nothing? Okay. So entity resolution. Entity resolution is something very, very interesting because it means that we are dealing with entities when we are working with slots. When we work with the slot, like for example, we have a slot called, for example, size, right? Tiny, large, small, etc. We call those entities, right? So let me give you an example. The slot size, okay? So we have tiny, small, medium, large, okay? Tiny, small, medium, large. So there are many ways in which a user can say small, right? They could say mini, they could say little, they could say petite, tiny, etc. So we call those synonyms. But the entity that these words are referring to is basically the entity small, right? So we call that entity. When the user says something that looks like an entity, it could be similar, right? Like a synonym, right? We need to create a resolution for that and see if we can resolve it to a specific value. So in the case of tiny, for example, the user might say mini, petite, teacup, that I can carry in my purse. They can be more complex than just words, right? And we can define those synonyms. When we create slots and slot types, we can define synonyms for a specific entity, right? Like the tiny entity or the small entity. So these are just examples. That allows you for more variation in how the user can answer. The user can answer with something similar, but we can immediately, thanks to this, map it to a specific entity. So if the user says little, in the code, we will get, in our backend, we will get a response that will basically specify that little was matched with an ER success match. ER doesn't mean error, means entity resolution. Entity resolution success match. So it's basically telling us that the value is little, which is what the user said, but it's been resolved to tiny because little was defined as a synonym of tiny, right? So basically this is a match and we have our value. We can work with this with accessing a database or an API, etc. Now, suppose that we have defined mini as a synonym to both tiny and small. That's supported, actually. Sounds a little bit weird, but that's supported. We will get different resolution values. The system will basically tell us that mini maps to both tiny and small. And then we need to make a decision there about what we want to do, okay? Depending on other type of context in the conversation, we'll get there. Okay. So what happens if the user says something that has nothing to do with the slot filling? Basically, the phrase follows the same structure where we would expect a size. Like, for example, I like a dog that size pizza, instead of I like a dog that size small, for example, to give you an idea. We have all the structure to define a size, but the user said pizza, right? So basically, we have an entity resolution success because we are in that utterance or in that phrase, but we don't have a match for that value. We have pizza, we haven't defined pizza. So in any case, we get the value, right? So we can decide on the back end what we want to do. We can decide that we want to say, I cannot deal with that, I don't know what that is, or we can do a search and do something else, okay? So we've been through entity resolution. Let's take a look at memory. Now, one of the worst things that can happen in a skill is that the skill doesn't remember what's going on, right? Or that can't hold its context. So basically, the user's saying, the skill asks for the user's name, you start an interaction, and suddenly the skill starts for the username again, right? So memory is super important. And there are, it's basically about customer delight, right? Like welcome back, John, etc. Means that the skills basically understanding what's going on in terms of memory, remembers the user. So there are two kinds, short-term memory, and a short-term memory we deal with it via session attributes. You can store attributes in the skill session. The whole session can store attributes. So this is a way in which you store it. So it's basically you get the session attributes and you can set it up, right? And then you can reuse it across the whole interaction of the skill. So if you basically grab the username and you store it in a session attribute, you can use it across the whole interaction to name the user every once in a while. We call this short-term memory. This is what the incoming request would look like when you are storing attributes. So as you can see over there in line 9, there's an attributes element, right? And then inside profile, you have allergies, location, etc. So this is a skill that it's about recommending food to the users. And the skill is basically storing specific information given by the user. Like, for example, I'm pescatarian, I'm allergic, etc. Storing that in sessions so it can be reused on different interactions within the same session of the skill. But this is short term. As soon as the session ends, we lose all of this, right? We are not making this persistent. So we also have long-term memory, and for long-term memory, we use DynamoDB as a convenience. You can use whatever database you want because you have a Lambda in JavaScript. You can access any service that you want. You can send the data to any service that you want. So we use this long-term memory system via DynamoDB because it's super convenient. The way in which it works is we provide the same interface that we provide for session attributes, right? Very similar interface, but we are actually storing the information in a database. So the next time you come back, you can actually retrieve that information. So this is more or less what the skill looks like. The pet match, for example, is using a Lambda. That's the front end over there, voice interaction mode. Then it's using a Lambda. It's using an API to consume the service that will actually recommend the pet. And then it's using DynamoDB to do the long-term persistence. So let's take a quick look at some of the code. When you are working with the backend, you have what we call handlers, and the handlers are supposed to deal with a specific request from the users. For example, if the user says match me, like the pet match example, that would be a pet match intent. Someone wants a match, someone wants a recommendation. And for that, we have handlers that can actually handle specific requests from the user. Those handlers, you have to specify them here. When you build a skill, you define what handlers are set up to deal with the user's command. But also, you can define that you want to work with the table, like over there with the table name, the foodie, and you can determine that you can create the table automatically. So basically, with 2 lines of code, you are actually telling the skill that it should create this database and it should support it. So everything that you store in the code that we're going to see in the next slides will be in this database. It's a DynamoDB database, and you can go check it out, etc. I mean, it's a full-blown database. So as I told you before, it's very similar to session attributes. You're basically getting the persistent attributes. The handler input, to give you an idea, it specifies everything that is incoming from the device. So when the device passes a request to your service, you will get JSON in, a very big JSON with all the information, like what locale the device has, what's the user ID of the user, what are the slots that the user specified. All the information is coming via this handler input, but we have also some convenient functions within the handler input, which is, for example, dealing with persistence. So you will basically access an attributes manager, and you will get the persistent attributes, right? And when you have as you can see, we're using a sync await because we're accessing a DynamoDB database, which is a different service. Okay, so we need to do this. So when you get the persistent attributes, you can store information. So in the third line over there, as you can see, we have the persistent attributes, and we are saying, I want to store allergies. This user is allergic to shellfish, and I want to store that, right? So after you do that, you just need to set them back and set the persistent attributes, and that will go automatically into the DynamoDB table. Okay, so as you can see here, this is an example of how to retrieve this is an example of how to save the persistent attributes, because after setting the attributes, you need to save them. So that's just an additional step when we compare to the previous slides. It's exactly the same slide, but we were missing the last line here, which is basically telling it to save the persistent attributes. But then we have the possibility to get the information back, right? So we would fetch the persistent attributes again, and we will assign them to the slots that we are trying to fill. When we are dealing with slots, we have this structure where all the slots are stored as in a tree structure, right? So we have slots and we have the different slots. Now we can get some of those slots from the DynamoDB table, and we can put them back into that slot structure, okay? Which is what we're doing in the line before the return over there. So what we're doing is taking the slots, taking the allergies value, and putting the value back from the database. Okay. Now that we have it back on the slot, we just need to give that information back into the interaction, into the dialog management. As I told you before, when we're doing dialog management, we're doing dialog delegation. And when we're doing dialog delegation, Alexa is independently trying to collect slot information, right? Now, what we just did here is pass this slot information that we grabbed from persistent storage to this interaction, so Alexa would not ask for that information when it's doing this back and forth, trying to fill in slots, because Alexa will know that these slots have been filled from persistent storage, and it will not have to ask for it again. So this is what you're seeing right here. So let me give you just a guide of some of the resources that you should definitely check. These are resources that are totally recommended. And why is it is that I'm trying to recommend these resources here? Because a lot of people get confused and think that maybe providing top-notch skills, it's more like a coding problem. We are more facing a design problem when it comes to building skills or advanced skills. The coding part is not really a big deal in terms of what you need to do in the back end. But there are much more challenges on the design side of the skill to provide natural conversations that can have dialogue that go back and forth, etc. So design is the number one thing that I would like you to take a look at. So if you go to alexa.design/guide, you have a full guide that basically teaches all the nuances of building for voice. We need to change our mindset when it comes to designing voice user interfaces. It's very different than creating a GUI, right? So the second guide is a resource that you can use to make your skill stand out among all the different things, which is basically about user delight and how to make those things that make a skill really, really good and really stand out. And we are also offering office hours to basically help you out with building your skill. And we are doing a lot of interactions in our Twitch channel. We have twitch.tv/Amazon Alexa. We are doing all kinds of sessions over there, so I invite you to get there and visit us. So there are a few promos that are specific to German developers, and I wanted to share this with you. If you have a phone, maybe you can take a picture of this to check later. But basically, when you create 3 skills, you will get an Echo Spot. And if you create 1 more skill, you will get the new Echo Show. The new Echo Show is a device that has a screen, right? And it's a very, very nice device in terms of audio and screen quality. Yeah, we also have a rewards program where we are paying developers that create engaging skills. So when you create a skill that is super engaging, super popular, Amazon is providing rewards. That's the second link over there, okay? And when it comes to what's available and what's not available in Germany, you can take a look at the feature updates over there, because the English model has some features that are not yet available for Germany. The central page, when you want to check anything that's happening with ASK or Alexa Skills Kit and Germany, is that bottom link over there. So everything will be there, even events. And let me just give you a hint of the events. If someone is going to Cologne today, you might be able to catch up on this one, which is 6:30, and then we have workshops in Frankfurt and Berlin. So these sessions, the workshops, are different from the session that we just have, because these sessions are more hand-on, right? So basically, we build a skill from scratch. So we start with the concept, we teach how to build it, and you will go home with a skill that's already built and maybe that you can modify to actually publish. Okay, so that's it. Thank you very much. Are we doing a round of Q&A? I don't know if...
This pet match example, this was just one intent?
Yes, it's called pet match intent. Correct.
Okay, the whole skill was just one intent, so it feels like one natural dialogue, right?
Yes, correct. This is a sample skill, so it's not a production level skill. It's basically been created to showcase dialog management, how to fill slot, how to collect slots, etc. It's uncommon to see skills that only have one intent, because you might want to complement your skill with something else. It's very common to see skills that provide a recommendation, but also provides maybe games or quizzes, stuff like that. But yes, in this case, it's just a very simple sample demonstration of dialog management.
Okay, thanks.
Okay.
Thank you for your talk.
Thank you.
My question is, what is the most common mistake people make when designing dialogues?
That's a great question, actually. The number one mistake is that if you think about it, we don't write the way we talk, right? So when you're coding a skill, your first impulse is to basically type the conversation, right? So when you're typing the conversation, basically start writing a blog. So my advice is that when you write that conversation, give that text to someone else, to a friend or someone, so they can read it out loud, and you will see that it's probably wrong, right? Most probably wrong. So it feels very unnatural. There are multiple rules or multiple tips that you should follow when it comes to designing for voice, and that's why I shared this alexa.design/guide link. And one very important rule, we call it the one breath test, which basically means that if Alexa is saying something that requires more than inhaling and exhaling, it's too long. Right? There are a lot of videos that show how there's like a cognitive overload as soon as you start getting a lot of text. There are other tips that it would be better if you just check them in this resource. But there's another one where we recommend to provide variety. For example, the skills are always saying goodbye in the same way, always saying hello in the same way. They are always playing like a welcome message as soon as someone starts using the skill. But what if you're coming back to the skill again and again and again and again? It becomes super annoying, right? So variety is one that is super important. And the one thing is that another very important thing is that you cannot expect the user to know what to do. There are multiple skills that say welcome, and they give no hint whatsoever on what needs to come next. So the user doesn't know what to do, and the user needs to start exploring, via trial and error what to do. You need to provide some kind of guidance. These are just 3 tips of tons of tips, probably 15 or more, that you need to follow that are common mistakes and that you can fix easily and quickly.
Thank you.
Sure.
Okay, hello. I also have a question. Is it also possible to build like private Alexa skills that I can also use just at my home?
Yep. When you build a skill, it's immediately available in your account. That means that if you have maybe 3 or 4 devices, Alexa devices, and you use the same account, you will have access to your skill, right, in all of those devices. Now, there's something else, in case you want to share it with a limited amount of people, for example, not only yourself. We have what we call beta testing. So when you create a skill, you can go to a tab when you're going in the distribution step of your skill, when you can actually invite beta testers to test your app, and only them will have access. So that's a good opportunity. For example, if you're creating like a family skill, right? You can add maybe your family members as beta testers, and they will have access to the skill. But yes, it's up to you. You don't have to go through the distribution and certification process if you don't want to. The thing is that obviously that skills are going to be visible by others, but the public at large.
Yes. Yeah. Okay, thank you.
Sure.
One short question about I'm here. About sharing skills or sharing data that is collected between skills. Let's say I have 2 skills very similar, and I'd like to use the data that are already collected from the other skill. Yeah. Or maybe you have a user profile in Alexa and you have a lot of information that could be useful for my skill. How can I share the data, or what are the limitations?
Yeah. So if you want to collect user profile information, like for example, suppose you have your own authentication system and you want to correlate the same user to different skills, right? So you have different skills and you want to basically know that this is the same user, you can use what we call account linking. Account linking is a way for you to use your own authentication backend using OAuth 2 to connect the skill to a specific user. Now, when you connect the skill to that specific user, you can basically grab information about what you are supporting in your own authentication backend, for example, email, right? Obviously, the user, when they are doing account linking, they have to authorize that link, right, via the app. So it's opt-in. They can reject it if they want. But the thing is that if you're using this account linking, you can actually use it for all your skills. So if you have 3, 4, 5 skills that basically need to deal with a single user and fetch information from a specific user, you can send this account linking card to them in the skill. And when they accept it, they don't have to do it again when they come back to the skill, right? They will have to do it in every skill that you are supporting. Having said that, there are also other APIs that provide basic user information that they are also opt-in, meaning that the user has to accept its use via the app. But it's basically sharing information such as telephone number, email, stuff like that, without the need for you to have your own authentication backend. Okay, so they basically specify that in the Alexa app. When they sign up, they can specify, for example, the device address. And then you can request that via API, and if they authorize it, you will get that information. So that will also be a way to basically get user information.
Thank you.
Sure.
Thank you. Can Alexa recognize the user by its voice and give that information to the skill?
It doesn't give you information. There's a feature we call voice fingerprinting, and that's coming later. It's not available right now. So that's basically recognizing the voice profile of the user, right? That's not something that Alexa shares as information or anything like that. But we will see some of that later. I'm not sure if that answers your questions. your question?
Yes.
Sorry.
Thank you. May I ask a second question?
Yes, sure, absolutely.
Is it possible for a skill to modify itself? So dynamically, let's say, changing its own dialogue while it's already deployed?
That's a good question. The voice interaction model cannot be modified. Okay, so when you build the voice interaction model, you define these utterances, you define what slots need to be collected, etc. That's a static model, and that static model goes into a machine learning process, and it gets trained, right? So the Alexa service takes a look at the model, takes a look at all the phrases, all the utterances, and trains a deep learning model to basically do the recognition. So doing dynamic changes is quite challenging because you are training a model, right? So suppose you go and modify something really quickly, you'll have to train the model again. So in general, the voice interaction models, you think about it as something static that you're training, and when you need to modify that, for example, you realize that there's something that is not recognizing, etc., you need to change that, save the model and build it again, and there's a deep learning model that's been trained again, okay? So having said that, in the backend, you can do whatever you want. You can dynamically change what Alexa is saying back to the user all the time. You can fetch information from third-party services to make Alexa behave differently, change the personality, change voices. For example, there's a way to use Amazon Poly voices, which is a system to generate voices. We have 22 options right now. So Alexa can answer back with different voices, stuff like that. So the backend is your realm. You can do whatever you want. You can change the behavior. You can even be testing a skill, voice interaction model, testing it live and changing the backend live at the same time. So as soon as you change it, you will see that Alexa is responding something different. So it's happening live. It's a different thing depending on whether we consider the voice interaction model or the backend. Okay. Anyone else? All right. Is there no more questions? Thank you very much. Thank you.